Hi everyone, this video is on the discriminant. So the expression b squared minus 4ac is called the discriminant, and what you'll notice is that is the expression underneath the square root in the quadratic formula. So when we have a quadratic equation, if the discriminant is greater than 0, the equation has two distinct roots. If the discriminant equals 0, it has two equal roots or one solution. And if the discriminant is less than 0, then the equation has no real roots. So two examples. The first one, find the value of the discriminant in these two equations. So for A, we've got our equation is, remember, b squared minus 4ac. So you've got A, B, C. So b squared, so it's going to be 5 squared minus 4 times 2 times negative 1. When you work that out, you'll get 33. Now, as the discriminant there is greater than 0, the equation has two distinct roots. You can say sometimes two distinct real roots. B, do the same thing. So first of all, we want to make it equal 0, and then we can work out the discriminant. So it would be 10 squared minus 4 times 1 times 25. Which actually equals 0. So as the discriminant equals 0, it has two equal roots. What that means is that the parabola is touching the x-axis at one point. Example 2, find the set of values of k for which the equation kx squared plus k minus 3x plus 1 equals 0 has no real roots. So this type of question does come up in IB exams where they want you to find a value using the discriminant. Now, in this question, the kind of hint that you'll be using in discriminant is it has no real roots. So more often than not, if it talks about two real roots, two equal roots, no real roots, then it's kind of a hint that you need to be using the discriminant. Now, no real roots means that the discriminant has to be less than 0. Or b squared minus 4ac is less than 0. Now, in an exam situation, just writing those statements there can sometimes give you 2 or even 3 marks. So always make sure with the discriminant questions you're writing everything out. Now, in this equation here, our a will be k, our b will be k minus 3, and our c will be 1. So we're going to have b squared, so we'll have k minus 3 all squared minus 4 times k times 1, and we want when that is less than 0. Now from here we need to expand the brackets, so we'll get k squared minus 6k plus 9 minus 4k. Simplify this down and we'll get k squared minus 10k plus 9 is less than 0. So now we need to solve the quadratic, and we need to solve it just like we did in the inequalities video. So we know that it would be k minus 1 and k minus 9 would equal 0. So k has to be 1 or 9. Now, when you have this situation like this and you've had to solve a quadratic in this form, you have to think about your graph. And be aware that this is often a non-calculator question. So if we think about the graph in this situation, we know it's crossing at 1 and 9, so it's going to be a bit like that in some way. This will be 1 and this will be 9. Now the question is, we want to know when this original quadratic has no real roots, which is when it's less than 0. So we're wanting the values where this graph is less than 0, which is here. So it is the bottom part of that graph between 1 and 9. So for this equation, in this quadratic in the question, to have no real roots, k has to be between 1 and 9. Now remember, this graph I've drawn here is not the graph of the equation that we're starting with, it's a graph of the discriminant. They're two different things. Okay, and we want when the discriminant is less than 0, which is, if you look at the graph there, between 1 and 9. And that's the discriminant.